Hi to everyone. I am Dr. VNSR Venkateswara Rao, working as Associate Professor in Institute of Aeronautical Engineering, Hyderabad. Today, I would like to give the topic on the batteries, primary cells. So, before giving the introduction to the batteries and primary cells, first of all, we must learn about the battery. Battery is nothing but one of the electrochemical cells, and these are considered as a source of direct electric current at constant voltages. Mainly, electrochemical cell is nothing but defined as the conversion of chemical energy to electrical energy and electrical energy to chemical energy. So, most probably, the batteries involves a series of parallel electrochemical series cells and connect in the series mode. So, batteries are mainly classified into three types: primary cells, secondary cells, and fuel cells. Batteries are converted into three types. First one, primary cells, secondary cells, fuel cells. So depends upon the type of the reactions involved in the batteries. These are mainly classified into primary cells, secondary cells, and fuel cells. So in case of the primary cells, the cell reaction is not reversible, whereas in case of secondary cells, cell reaction is reversible. Primary and secondary, this is the difference between the these two cells. That means primary cells are not reversible, secondary cells are reversible. In case of the fuel cells, mainly takes place the chemical energy converts to electrical energy by the oxidation of the fuels. Oxidation of the fuel. So this is the basic definition for the primary cells, secondary cells, and fuel cells. In case of the primary cells, chemical energy converts into electrical energy only. But whereas in the case of the secondary cells, chemical energy converts to electrical energy and electrical energy converts to chemical energy. Whereas in case of the fuel cells, the oxidation of the fuel converts into a chemical energy into a electrical energy. That means the generation of power takes place. In case of the primary cells is also called as a disposable batteries. Primary cells are called as a disposable batteries. So means primary cells are used in through type, that means disposable batteries, whereas secondary cells are used, the chemical reaction converts into a forward and backward reaction. That means chemical energy converts to electrical energy and electrical energy converts to chemical energy. That means these, in the case of the secondary cells, these are possible to charging the batteries. That means charging is possible. Use more and more. Uses number of times. So in case of the fuel cells, there is no storage of energy. No storage of energy. So this is the main classification and differentiation between the primary cells, secondary cells, and fuel cells. Finally, we finish this classification. Nothing but what are the examples of batteries, primary, secondary, and fuel cells. Primary cells examples are the Leclanche cells, and fuel cells are defined as secondary. The examples of primary cells are the Leclanche cell, and secondary cells are the nickel cadmium cells, and fuel cells are the hydrogen oxygen fuel cells. Hydrogen oxygen fuel cells. So this is the best examples for the batteries. So this is the just a brief introduction of the batteries with their classification. So the batteries are nothing but a chemical cells. That means electrochemical cells. In these electrochemical cells, mainly the energy conversion possible from chemical energy to electrical energy and electrical energy to chemical energy. But according to the definition of the primary cells, only forward reaction is the possible. That means chemical energy converts to electrical energy, but not electrical energy into chemical energy. So these batteries are mainly called as a disposable batteries. batteries are primary cells. The best examples of the primary cells are the Leclanche cell, and in case of the domestic purpose, most probably these are used as a digital watches. So these are the general examples of a primary cells, and these primary cells are also called as a dry cell. The example for the dry cells is a Leclanche cell. That means in case of the electrochemical cells, anode system chemicals are the different from the cathode system chemicals. That means anode is different from the cathode. Why? Because the reaction occurs at anode is the oxidation, whereas the reaction occurs at a cathode is a reduction. The reaction occurs at cathode is a reduction, but finally the net cell reaction is a redox reaction. That means the redox reaction means the reaction simultaneously takes place both oxidation and reduction. A primary cell is defined as a kind of battery in which the electrochemical reaction is not reversible. That means rendering the cell non-rechargeable. That means these are the disposable batteries. The examples for the primary cells are the Leclanche cell and lithium cells. So most probably today's we use the lithium cells when compared to the Leclanche cell. So a primary cells becomes polarized when used. That means hydrogen accumulates at the cathode and disposable at the effectiveness of the cells. To eliminate this, depolarized is used, and this may be mechanical, chemical and electrochemical. That means in case of the primary cells, what happens, the ions present in the electrolyte solution will be dissociated into individual ions, gets polarization. That means chargeable particles will be occurred. So because of the avoiding of this polarization, we use the depolarizer. The depolarizer may be either mechanical or chemical and electrochemical batteries. That means primary batteries are not economical but have a power of self-discharge rate and can be stored for a longer period. That means primary cells find applications in smoke detector devices, cameras, clocks, hearing aids and watches, etc. So this is the mainly useful for the domestic purpose batteries. So what are the applications of the domestic purpose? Smoke detectors devices, cameras, clocks and hearing aids and watches, etc. So this is the basic diagram for the primary cells and the best example for the Leclanche cell. That means these are totally how many components? We see the total components are first component top cover, and second component asphalt seal, and third component carbon rod, fourth component separator, and fifth component is the zinc container, and sixth one is the bottom cover and negative terminal, and seventh component is the positive terminal, eighth component is airspace, ninth component is manganese dioxide, 10th component is electrolyte, 11th component is the paper or metal jacket. That means this Leclanche cell containing the totally 11 components. 11 components. So out of the 11 components, there is a must and should two components. That means positive terminal lies at the top of the position and negative terminal lies at the bottom of the position, and top cover to avoid the exposure to the outside unit, and asphalt seal can protect the cell cannot be exposed to the outside environment, and carbon rod is placed at the center of the graphite rod, and separator will be takes place it will be avoided the connection of the both positive and negative terminal, and zinc container present in the zinc sulfate solution, and airspace also required to avoid the exposure of the outside, and manganese dioxide is also present at the bottom and center of the cells, and electrolyte solution which occurred in the electrochemical reactions, and finally paper at metal jacket side. So these are the totally 11 components of the primary cell and involved in the Leclanche cell. So primary cells, Leclanche cell will also see like a jar model type. It is also containing the totally how many components? First one is the pitch component, and second one is the glass jar, and third one is the ammonium chloride solution, and fourth one is the porous part, fifth one is the carbon rod, and sixth one is the mixture of the carbon and magnesium dioxide, and seventh one is the zinc rod. So these are the components which are present in the jar type Leclanche cell. So in case of the top component, pitch component, to avoid the exposure to the outside, and the second one is the glass jar. Mainly it contains a aluminum chloride solution, AlCl3. aluminum chloride solution, and bottom observe the porous part, and final one is the carbon rod. This carbon rod can be acted as a graphitic rod, and finally observe the bottom of the jar is the mixture of carbon and magnesium dioxide, and top at the position zinc rod will also place. Totally this jar component Leclanche cell containing the 7 components. So these are the examples for the primary cells for the Leclanche cell. That means the primary cell, nothing but the cell reaction is not reversible. Only forward reaction is possible. That means chemical energy converts into a electrical energy only. So what are the reactions takes place at Leclanche cell? It already contains explain the both anode and cathode. So what is the reaction takes place at anode? That means oxidation reaction. That means zinc undergoes a zinc 2 electrons to get a oxidation reaction. And at the cathode, what happens? These 2 electrons lost at the anode received by the manganese dioxide in the presence of a ammonium chloride solution. In the presence of a ammonium chloride solution, we get a MnO3 and ammonia with water chlorine molecule. Finally, that zinc and ammonia mixer to give a zinc ammonium chloride. So totally, what is the Nessel reaction? Zinc reacts with the 2 moles of manganese dioxide and 2 moles of ammonium chloride to get MnO3 plus zinc ammonium chloride with the water molecule. That means in the case of the Leclanche cell, actually the components present in the that means the chemicals present in the Leclanche cell are converted into polarizers. So we need to require the depolarizer. So in this case, manganese dioxide can be acted as a depolarizer. Manganese dioxide can be acted as a depolarizer, and electromotive force of the cell should be equal to the 1.2 volts. Electromotive cell of the cell is equal to 1.2 volts. So this is the cell reactions which are occurred in the Leclanche cell. So this is the first example of a primary cells. That means mainly we discuss about the primary cells involved in the batteries, which involves the cell reaction is not reversible. That means chemical energy converts into electrical energy. So totally how many components in the Leclanche cell? First of all, we see Leclanche cell in the first model, it contains 11 components. That means top cover, asphalt seal, and carbon rod, separator, and zinc container. And bottom cover and the negative terminal and positive terminals are very, very important. This can be acted as both anode and cathode. And airspace for the reaction rates. And manganese dioxide can be acted as a depolarizer. And electrolyte which occurs in the chemical reaction takes place at anode and cathode. And finally, observe paper or metal jacket at the bottom. This is a basic type of a Leclanche cell. And Leclanche cell which are present in the jar type model. This jar type model is also containing totally 7 components. That means first component is pitch model, and second component is the glass jar, third component is the ammonium chloride solution, fourth part is the porous part, fifth one is the carbon rod, and the seventh one is the zinc rod which are present in a jar type model. And finally, observe mixture of carbon and magnesium dioxide, manganese dioxide. So this is nothing but the cell reactions which are takes place at the Leclanche cell, especially at anode. What happens? The oxidation of the zinc takes place, and at what happens at cathode? The reduction of manganese dioxide takes place with the releasing of the main products, nothing but zinc ammonium chloride. So the next cell reaction will also give the manganese dioxide and zinc ammonium chloride with water releaser. So in this case, the reactant manganese dioxide can be acted as a depolarizer, and the electromotive force of this cell is nothing but a 1.2 volts. It is very, very important the how much voltage generated in the Leclanche cell should be equal to the 1.2 volts. So, and the second best example for the primary cells are the lithium cells. Lithium cells. So, in case of the lithium cells, what happens? It is nothing but a coin type batteries. That means which is very, very easy to move from one place to another place. It is also can act as a primary batteries which cannot be recharged phenomena. That means according to the definition of the primary cells, these are applicable to a only forward reaction is possible. That means chemical energy converts to electrical energy, but not electrical energy to chemical energy. The same principle will also applicable to the in the case of the lithium cells. So lithium cells see like just like coin type batteries. It may be either a big diameter or lower diameter coins. So in the case of the lithium batteries also containing the how many components? Manganese dioxide can be acts as a cathode, and separator is there, and lithium anode and anodic cap, and fifth one is the heel, and sixth one is the carton can. So totally how many components present in the lithium cells? 6 components. 6 components. So in the case of the lithium cells also mainly it involves the 2 covers. One is the top cap and last one is the bottom cap. Top cap and bottom cap. In between this top cap and bottom cap there are so many parts which are involved in the lithium cells. So that is the second one is the readout devices, and third one is the current location sheet, and fourth one is the lithium metal slice, and fifth one is the isolation diaphragm, and sixth one is the temperature sensor, and seventh one is the isolation diaphragm, and eighth one is the cathodic electrode. So these 8 components are the very important. Out of the 8 components, temperature sensor is the most important. Why? Because the chemical reactions will also affect the temperature, which is very important for the lithium cells. So in this lithium cells, solid cathode is the lithium cells, and lithium metal acts as a anode. Lithium metal can act as a anode. Manganese dioxide solid can act as a cathode, and lithium salt dissolved in the non-aqueous solvent acetonitrile medium acts as a electrolytic solution. So it is also containing the how many parts? Only first one is the cell top. Cell top devices, that means it can act as a negative terminal, whereas B part can be considered as a anode of the lithium. Anode of the lithium, and part C can be considered as a nylon seal. Nylon seal. And D part can be considered as a electrolyte separator, both anode and cathodic material. That is nothing but a part D, separator, and E part nothing but cathode of manganese dioxide, and F part nothing but absorbent separators containing the electrolyte, absorbent separators, and last one G nothing but a cell can, that is nothing but a positive electrode. So that means the negative electrode placed at the top of the cell, and the positive electrode lies at the bottom of the cell, and it contains at the starting of the cell nylon seal which can protect the outside exposure. And in the case the lithium can act as a anode of the cell, and it can be divided into a separators, especially manganese dioxides, and separators which are electrolytic in separator, both anode and cathodic material. So absorbent separators are required for the lithium cell. So what are the reactions occurs at a solid cathode lithium cell reactions? That means at anode what happens? Lithium undergoes a oxidation with the loss of the 1 electron. And what is the reaction takes place at cathode? Manganese dioxide with lithium molecules that absorbs that lost electron and converts into manganese dioxide lithium molecule. That means cell reaction is lithium reacts with the manganese dioxide to convert into manganese dioxide with lithium. So manganese dioxide is reduced to trivalent state from the tetravalent state by lithium. Manganese dioxide is reduced to the trivalent state, means plus 3. and tetravalent state means plus 4 state by lithium molecules. That means their oxidation state will be reduced. And the electromotive force of the cell should be equal to the 3 volts. So this is the about solid cathode lithium cell reactions. So this is also one of the best important type of the primary cells. But but the cathode of the lithium present in the physical state nothing but a solid. So it can be called as a solid cathode lithium cell reactions. So, and the second important lithium cell is nothing but a liquid cathode lithium cells. Liquid cathode lithium cells is also containing a liquid metal acts as a anode, and thionyl chloride liquid can act as a cathode. Thionyl chloride, and formula of thionyl chloride is the SOCl2, thionyl chloride. And lithium salt dissolved in the non-aqueous solvent thionyl chloride medium can act as a electrolyte. That means these are the main components present in the liquid cathode lithium cell. That means first one is the liquid cathode is the lithium cell, and medium metal can act as a anode, and lithium metal can act as a anode, and thionyl chloride liquid can act as a cathode. And the formula of thionyl chloride is the SOCl2, and lithium salt dissolved in the non-aqueous solvent thionyl chloride medium acts as a electrolytic solutions. So, and what are the reactions takes place at liquid cathode lithium cell reactions? At anode, what happens? The lithium undergoes a oxidation with the loss of the 4 electrons. And at cathode, what happens? The thionyl chloride dissolved lithium absorbs those 4 electrons, converts into a lithium chloride with byproducts of the sulfur and sulfur dioxide. And what is the cell reactions? These lithium molecules reacts with the thionyl chloride to give a lithium chloride with the byproducts of sulfur and sulfur dioxide. That means 4 moles of the lithium reacts with the 2 moles of the thionyl chloride to give a 4 moles of lithium chloride with byproducts of sulfur and sulfur dioxide. And finally, observe the EMF of the cell should be equal to the 3.5 volts. 3.5 volts. And finally, observe what are the advantages of the lithium cells. So exhibits voltage up to nearby 4 voltages compared to the primary cells of Leclanche cell. It is more better, and it gives a better output energy. And operating temperature mainly should be equal to the minus 50 degrees centigrade to 70 degree centigrade. So it has a long lifetime, and it should be produce a good conductivity. And various types of the applications used in the lithium cells. So it is mainly applicable to the usage of wide ranges. And coin size of the batteries typically having the 20 millimeter in diameter and 1.6 to 4 millimeters thickness. The dimensions are very important. 20 millimeters in diameter and 1.6 to 4 millimeters thickness of the batteries. So this is about the advantages of the lithium cells. And what are the uses of the lithium cells? So almost all the lithium batteries are very commonly used in the so many applications, especially portable electronic devices and clocks, watches, PDAs, camcorders, digital cameras, thermometers, calculators, personal computers, BIOS firmware, communication equipment, and remote car clocks. So this is about the main use of the lithium cells, and these are also many long lifetime critical devices such as pacemakers and other implantable electronic medical devices. That means this is not only applicable to a domestic purpose, even in the case of the medical field also this is mainly implantable electronic medical devices. These devices are specialized lithium iodide batteries designed to last 15 to or more years. That means from last 15 years to this can be acts as lithium iodide batteries, especially for the dental devices. So this is about the second type of the lithium cells. So first of all, lithium cells are mainly classified into 2 types. That means solid liquid lithium cells and liquid lithium cells. solid lithium and liquid lithium cells. Solid lithium cells and liquid lithium cells. So these lithium cells are also nothing but is a under name of the coin cells because of the shape of the lithium cells present in the form of the coin. So this can be acts as a primary batteries and which cannot be recharged according to the definition of the primary cells. So this coin component containing totally 6 components. These out of the 6 components, the temperature sensor is the very important factor. So this temperature sensor mainly applicable to the which affects the rate of the chemical reactions takes place in the lithium cells. So temperature sensor is the part of component is the very important in the case of the lithium cells. So this lithium cells are in the phenomenon of like showing in the form of the coin type batteries, and the main circuit diagram containing the lithium cells are the 6 components. The first one is the manganese dioxide cathode, and second one is the separator, and third one is the lithium anode, and fourth one is the anode cap, and fifth one is the seal to protect the outside environment, and final one is the cathodic can. So these are the main circuit diagram components containing the 6 components, and coin cell lithium cells containing the totally 9 components. So out of the 9 components, temperature sensor is the very important. So the first one is the solid cathode lithium cells. The solid cathode lithium cells will also containing the totally how many components? 7 components. These 7 components will also observed in the negative terminal present at the top of the cell and positive terminal observed in the at the bottom of the cells. It is also containing the totally manganese dioxide and electronic separator, which is mainly of the lithium can act as a anode of lithium cells. In this case also we observe the absorbent separator cells also present in the lithium cell. So in the case of the lithium cell, the cathode of the lithium cell, and mainly the lithium metal can act as a anode. This is very important. What is the anode? Lithium metal. Lithium. So this is the present in the first group of the periodic table, and it is very rare earth element. So because of this rare earth element, the cost of the cell is some more high when compared to the Leclanche cell. And manganese dioxide can act as a cathode, and lithium, that salt dissolved in the aqueous nothing but acetonitrile solvent. This is one of the organic solvent. Organic solvent. So the presence of this acetonitrile medium can act as a electrolyte for the occurring the chemical reactions. So this is the solid cathode lithium cell reactions. What happens? The lithium undergoes oxidation at anode, and what happens at cathode? That loss of the electron by the lithium released by the in the presence of manganese dioxide and comes into manganese dioxide lithium. So what is the cell reaction? This lithium reacts with the manganese dioxide to get a manganese dioxide lithium molecule, and this manganese dioxide is reduced to a trivalent state to tetravalent state by the lithium molecules, and manganese dioxide converts into a trivalent state to tetravalent state. Trivalent state converts into a tetravalent state. That means manganese dioxide reduced to a trivalent state from the tetravalent state. Trivalent state to tetravalent state. And finally, because of this chemical reaction, what is the EMF of the cell? Nearly should be equal to the 3 volts. So this is very important for the solid cathode lithium cells. So the EMF of the solid cathode lithium cell should be equal to the always 3 volts. So next we revise the liquid cathode lithium cells. This liquid cathode lithium cells nothing but the lithium metal can act as a anode. The lithium metal can act as a anode. So this is also the first group element of the lithium present in the one of the alkali metals of the first group periodic properties. And thionyl chloride liquid can act as a cathode. The formula of the thionyl chloride is nothing but SoCl2. And lithium salt dissolved in a non-aqueous solvent, nothing but thionyl chloride medium, can act as a electrolytic solution. So because of this thionyl chloride organic medium will also affects the chemical reactions takes place at the cell, that means anodic oxidation and cathodic reduction. So what happens at anode? The lithium molecules undergoes a oxidation by the loss of the 4 electrons, that means 4 moles of the lithium to give the Li plus to give the 4 electrons, that means oxidation of the number of the electrons takes place by the 4 electrons. And what happens at cathode? This thionyl chloride reacts with the that 4 electrons with lithium molecules to give a lithium chloride solution, and byproducts are mainly sulfur and sulfur dioxide. That means overall cell reaction is the lithium reacts with the thionyl chloride to give a lithium chloride plus sulfur dioxide, and the EMF of the cell is equal to 3.5 volts. That means the EMF of solid cathode lithium cell is 3 volts, and EMF of liquid cathode lithium cell is 3.5 volts. That means the EMF of the liquid cathode lithium cells will be greater than the EMF of the solid cathode lithium cells. This is the resultant phenomena of the in lithium cells, especially solid cathode lithium cells and liquid cathode lithium cells. That means the EMF of the lithium cells from increases from solid cathode lithium cell to liquid cathode lithium cells. So previously observed in the solid cathode lithium cells only 3 volts, but liquid cathode lithium cells observed in the 3.5 volts. That means the electromotive force of the solid cathode lithium cells will be less compared to the electromotive force of the liquid cathode lithium cells. That means the working efficiency of the liquid cathode lithium cells are the more when compared to the solid cathode lithium cells because of the liquid media. And so already we observed the advantages of the lithium cells, nothing but exhibit voltage up to 4 volts. So in case of the solid cathode 3 volts, whereas liquid cathode 3.5 volts, and it will be rounded to up to a 4 volts, and it gives a high output energy when compared to a Leclanche cell, and operating temperature should be equal to -50 to 70 degrees centigrade, especially observed in the industries like pharmaceutical industries. Especially they maintain very low temperature, -50 to 70 degree centigrade, and compared to the remaining cells these are having a very long lifetime. So and the conductivity will be very high. That means it produces a high conductivity, and the conductivity is nothing but a reciprocal of the resistance. That means the mobility of the ions will be very high in case of the lithium cells because of these properties. That means voltage is high, output energy is very high, and operation temperature having the very wide range between -50 to 70 degrees centigrade. This will be useful for both domestic purpose and industrial purpose. So based on all these situations, this is mainly applicable to the wide usage, and coin size type batteries will be observed in the 20 millimeters diameter and 1.6 to 4 millimeters thickness. This is very the dimensions of a coin size lithium battery. Dimensions of coin size lithium battery. So what is the diameter? 20 millimeters diameter, and the thickness is 1.6 to 4 millimeters thickness. So this is the coin size batteries of the lithium cell dimensions. And what are the finally observe the use of the lithium cells? So almost all the lithium batteries are commonly used in the small and portable electronic devices, because the structure of the lithium cells are the coin size. So because of the structure of the lithium batteries, these are mainly applicable to the small and portable electronic devices. Small and portable electronic devices. That means especially used in the calculators, watches, cameras. So almost all the comes under category of the portable electronic devices. So especially clocks, watches, camcorders, digital cameras, thermometers, calculators, personal computers, especially BIOS, firmware, so and communication equipment and remote car clocks. All of these comes under category of the portable electronic devices. So the uses of the lithium batteries in these cases, especially portable electronic devices, is very high. And so because of the use of the lithium cells, mainly many long life period and critical devices such as pacemakers and other implantable electronic medical devices. That means not only a domestic and industrial purpose. So these are mainly applicable to the medical devices. In the case of the medical devices, nothing but pacemakers and implantable electronic devices. So especially these are useful for the medical devices in the case of the dental field. So the devices use specialized lithium iodide batteries. Lithium iodide batteries designed to last 15 or more years. That means recently these are applicable to the in the case of the domestic, industrial and medical field also. So this is the very important nature of the lithium cells, one of the primary cells. So finally, these primary cells classified mainly two types. First one is the Leclanche cell. Second one is the lithium cells. Further, these lithium cells can be converted into solid lithium and liquid lithium cells. So all of these observed within the only forward reaction will be possible. That means this can be used as a disposable batteries. That means chemical energy converts into a electrical energy. Only forward reaction is possible. So this is about the reactions occurred in the primary cells, nothing but Leclanche cell, solid lithium and liquid lithium. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.